everybody, welcome back to the Cloud Security Alliance's Cloud Threats and Vulnerabilities Summit for 2025. My name's Nate Lee. I am the CEO and founder at Cloudsec AI, where we help companies build secure agentic systems. And today I'll be talking a little bit about something that we've developed at the Cloud Security Alliance, which is a way to use traits to identify risks in agentic systems. The way you can think about that is that these agentic systems are made up of many different components that interact in all different ways, and it's really hard to understand how all that can go wrong. So as a system designer, it's hard to understand how you should be securing that. So we're going to talk a little bit about how you can understand how these systems are made and how you can use that to identify what can go wrong and, of course, to address it. So up first, we'll talk a little bit about what agentic systems are. So we'll dive into the different components a bit, but really just what are we talking about when we're saying agentic systems? We'll talk about why you might want to use a trait-based framework to identify what can go wrong. We'll describe the framework itself, and then we'll give you some practical examples so you can see how you might be able to use this in your own day-to-day work. We'll show about how these traits can inform questions that you can ask. And this is really important because those questions are what's going to inform you about what can go wrong in the system. And then from there, you can figure out what to do about it. And when it comes to agentic systems, it really does require a change in thinking. It's very different from traditional systems that are more deterministic. You get these emergent behaviors because they're able to kind of think and do things on their own. And when you kind of multiply that with many of them doing things together, obviously, there's a lot more room for interpretation, let's say. So that also means there's a lot more room for security issues. And we want to help shift the way people think about these systems so that you can better identify what can go wrong and, again, what to do about it. So first up, what are we talking about when we say agentic systems? Well, really briefly, this is just a system, generally a software system, let's say, and it's one that makes decisions, and then it's going to take actions. It's going to do that towards a goal, and it's going to do that based on inputs. It generally will do it without oversight. You probably hear about human in the loop, but the ideal goal that we're trying to get to is that these agents are doing all this work. They're taking inputs, they're making decisions with a bunch of context, and then they're deciding to take an action and they go do things without you or I having to really intervene in that. One thing to think about it is, isn't that just software? And to some extent, yes, it is just software. I mean, that's not wrong. But what makes agentic systems different is the fact that they're based on these large language models, which at this point everybody is fairly familiar with. And the thing is that these agentic systems, they can iteratively plan. So they can see what happens, they can try something, and if it doesn't work, they can try to pull in more context to understand what happened. And then they can try to come up with a new plan and execute on that. And that's because they're not programmed to do any one specific thing. They're programmed to achieve an objective. And sometimes it's even to figure out what that objective is and then go achieve the objective. And they're meant to do that autonomously. So you give them an objective, you give them a bunch of tools and the context to understand what the problem is, with the expectation that they will then adjust based on this new information to still go and achieve the goal. That allows them a lot of power because they can react to unpredictable environments. So if something happens that maybe makes the environment different, makes it a little more difficult to complete the job, it's very possible for them to understand why and try to come up with an alternate path that will solve the problem. So again, that's what makes these agentic systems different from just traditional software and trying to secure traditional software. They're able to adapt. And so when we think about traditional threat modeling and where that may or may not quite work well, there's the obvious thing here, shortest route calculated, it shoots off the cliff. Hopefully that is not something any of us will be worried about. But if you think about the traditional software, it's pretty deterministic. You have maybe some conditions that, hey, if this is met, go this way. If this is met, do this. They're structured inputs. You probably just have some JSON or whatever it is, a database where everything's in its own field, and generally some fairly well-defined system states. Now, on the agentic side, that may or may not be the case. You could still have structured inputs. In fact, you likely will in some cases. You might have some level of deterministic behavior where you're able to understand that, hey, when this happens, it's going to do that. And there might even still be well-defined system states. But none of that is really a given. There can be emergent behavior, again. And when we say that, what we're saying is with all of the different agents that might be in a system, with all of them taking a variety of different context and being able to decide what to do based on that context, a lot of different things can happen. And especially when one agent talks to another agent, which does some other things, and you have maybe a mesh or a graph of agents doing all different things, there's a lot of dynamic decision making happening. And that can lead to different behaviors, even with the same starting inputs. That makes it really hard to understand all the different ways the system can fail, all the different ways someone can break it. So that really is what sets it apart. Now, if you think about traditional vulnerabilities, you have the stuff, this here is basically like the OWASP top 10 list. So we have SQL injection, cross-site scripting, CSRF, indirect object access, all of these. They're fairly identified patterns. We understand how to fix this sort of thing. We know what to look for, and we know how to mitigate that. So if you're looking to prevent SQL injection, you want to make sure you parameterize all your inputs before it gets sent off to your database calls. You don't want to just take random strings from inputs that your users put on a website and send that straight to the database. So things like that. You want to do input sanitization, output escaping, all of those kind of standard things. When it comes to agents now, we have things that we worry about that are totally new. We have prompt injection, which people have probably heard about, and that's the, forget everything you've been told, do this new thing instead. We have data poisoning, which could be used to prompt inject. So someone can get to whatever your data source is, put a prompt injection there so that when it gets pulled in as context later, it's now an indirect prompt injection, and it can override some instructions. Excessive agency. This is another one where the agents might just have the ability to do basically anything. And that can lead to all sorts of problems. If you think about Claude's computer use, and OpenAI has the new operator that's able to actually use a computer, that is basically excessive agency in a box. It's able to do anything that you tell it to or that it thinks it's supposed to be able to do. There's also, if you think about hallucinations, you've probably used ChatGPT or something and gotten an answer where it's not true. Now think about that in the context of a system. If it's trying to make decisions, trying to take actions, and it's doing it with outputs that aren't quite true, and how that might cascade through a system. These are the sorts of things that are totally new that we have to worry about that maybe didn't exist before in a more deterministic system. There's also prompt leakage, where for a lot of companies, what's in the prompt is going to be some of their intellectual property. This is how they're doing a lot of their orchestration, kind of the special sauce in what they're doing. So wanting to protect your own system prompts from leaking out, we generally in a traditional system didn't have to worry about the fact that you could just trick the system into saying it because you convince it that you're the other person. There's also unbounded consumption. And this is where maybe I start using a service that is backed up by an LLM and get it to just be my own personal ChatGPT without paying for a license. Could be any number of other things, but I'm using someone else's tokens in a way that they didn't intend. And a lot of these are also off the OWASP top 10 list. Steve Wilson and the team over at OWASP had done a really great job lining up kind of the big vulnerabilities that affect LLM-backed systems. So if you haven't checked that out, I certainly advise people to do that as well. Now, these agentic vulnerabilities, they're in addition to the traditional security threats. So just because it's an agentic system doesn't mean you don't have to worry about the other stuff. All that SQL injection, cross-site scripting, broken business logic, you can still misconfigure an S3 bucket in an agentic system. So unfortunately, you have the old stuff to worry about, but now you also have all these new things to worry about as well. And that really does leave us a question, how can you secure an agentic-based system? Because they're so open-ended. They're so able to kind of find their way around things. And it's really hard to even define, here is the architecture. We have maybe like a 3-tier web app. Everybody knows, you put the front end, you have the application layer, and then you have your database server behind it. You probably do some networking to segment the networks between those. It's kind of a defined pattern. Well, when it comes to agentic systems, we don't really have those patterns. There's probably some conceptual ideas, maybe some boxes that show, a vector database where you're storing your context that you're going to pull back out, some API calls, there's an orchestrator, but that isn't really much more than just a conceptual idea of how you can build these things. So one of the challenges we wanted to deal with is how can we make it so that you can understand these systems in a more generic sense of what could be there and what does the implication of that existence of this thing mean in an agentic system. And to deal with that, we came up with the idea of doing a trait-based approach to threat modeling when it comes to agentic systems. And threat modeling can sort of turn people off because it sounds like big and heavy, and you've maybe done some exercises before that nobody really wants to squeeze into the dev process. This really is meant to be much more lightweight and just a way to think about it, like a mental model to think about how agentic systems are and what that means. Because when you think about how different systems could be, it can be a lot of different things. It could be a combination of all of them. So to say that here's the architecture you should build really leaves out the fact that there's a lot of ways you might want to build it. So we built out these different traits and patterns. And what we're talking about here when we say traits are the things that you see in bold. So control and orchestration, interaction and communication. Those are kind of functions that'll be within an agentic system. And then a pattern is how that trait might manifest. So in control and orchestration, you might have a centralized orchestrator that tells all the agents what to do. But you might have a fully decentralized system where the agents are deciding independently and autonomously what to do. They're coordinating with each other. So those kind of could fall on one end or the other. You might even have a little of both in your system. So as opposed to just saying this is how the system should be built, we understand that people are building them in many different ways. But the things that matter are how these patterns manifest. Because if you're building a decentralized system, you have to worry about certain things. And if you're building a centralized system, likewise, you'll have to worry about other things. And the same goes for the rest of these traits. Depending on how you take in sensory inputs for your agents. If it's just limited to, here's the input, it's an API call, versus does it understand the context of what the API call is made in and the rest of the systems around it, versus does it try to infer the intent of the person who made the API call and then base its actions on that? There's a lot of different ways that these systems can be built that are a bit more abstract than just saying, do you have a database or not? So we tried to think through how we can make this usable in a really flexible manner. And so if we think about practical examples for this, the easy one, of course, is just that first one I mentioned, control and orchestration. On one hand, you have centralized control. The other hand, you have decentralized control. And fairly straightforward what that actually means and what that could potentially drive. But what's more interesting here is understanding these patterns can help drive some questions. So if you see that you have a centralized system, or if you see that you have a decentralized system, again, there's a lot of different things that might mean depending on the context of your broader system and what it's trying to do. So really what's important then is to turn that into questions. Like if you have a decentralized pattern, so you have agents that are able to interact with each other directly, how can they manipulate each other? What ways could that happen? And then you can start thinking through what you can do about it. How do you prevent malicious commands from being issued? So then you start getting into, well, how do the agents take commands from other agents? Do they take commands from other agents? Where do they come from? How can that happen? Because now you have a distributed footprint that all of these commands could be coming from. There's also ensuring consistent policies. Obviously, if you have agents all over the place, they're sort of distributed. How do you make sure they have a consistent policy of like what their goals are, what their limits are? How do you make sure that that gets enforced? There's more practical concerns like tracing root cause. And it doesn't have to be because there was a breach or because there was an outage. Say you just wanted to know, why did this thing happen? And if it's one agent talk to another agent, and made this agent do this other thing, if you don't have a really solid way to trace that call all the way through the agents, it's going to be very difficult to understand what happened here and to be able to change that behavior going forward. So these are the types of questions you want to ask, because asking them up front enables you to make a decision about what to do about it. And it might be that you don't do anything, but at least you're making that as a conscious decision of what you want to do in your system design. And when we talk about some of the mitigations, again, this is just to show some practical examples, not to really dive deeply into any of these. But if you have a decentralized pattern, some of the things you could think of would be, let's have granular authorization. Think about message level authorization. So you're not just trusting things that come in. You probably want to verify permissions for each thing instead of just, hey, whenever it comes in, we'll assume it's all good, because you don't know at this point. It's coming from all over. You can't just say the orchestrator already checked this. Who knows what happened with the other agent? So these are the types of things you want to think of when you talk about mitigations. Least privilege, of course, just probably generally a good idea, but even more so when you have all of these agents running around, able to do different things. you really want to think through what specific privileges does this agent need? Can I restrict it to just that? And that really can help limit some of the blast radius of having so many different agents with so many different tasks going on. Generally, zero trust, again, a really good idea. Certainly a worthy goal, even if it's a lot of work, to just constantly be inching towards that. And especially when we're talking about agentic systems and as they get more and more complex, there's really a lot of value in making sure that you're thinking through zero trust principles and figuring out how you can implement them throughout your system. Now, the traits that we showed, there's the trust trait, there's control and orchestration, there's learning, all of these. The one thing to keep in mind is that the patterns that show how these traits manifest, they're not just a black and white thing. It's not binary, you're this or you're that. They can be on a spectrum. So if we talk about trust, what that means is you might have something where it's boundary based, where, hey, it's in the network and anything inside my network I trust, probably the opposite of zero trust, but that is a way you might build a system, and you probably have seen systems built. On the other end, you have continuous verification, which is much more in line with zero trust. But somewhere in between, there might be something like session-based trust, where when you get a request in, you're probably just doing standard authorization or authentication, but you're doing that based on the session, not for every single request for that session. So it might be that some parts of the system have part of this, some parts of the system are doing something else. It doesn't have to be that the system is all one or the other. So it's just worth thinking about. And that's, again, one of the benefits of thinking about the system as trait-based, because then you can start taking into account the implications of each different one, not that it's set in a fixed, rigid box where it has to be certain things you're worried about. When we talk about trust, obviously multiple patterns can exist, and it really can be a lot of different ways. So it probably is going to be, especially as your system grows, that you're thinking about building it one way, you get it started, and so you build that, but then you start tightening security bit by bit, and you're probably going to start in the more sensitive areas, in which case now you're going to have different pieces of your system. So it really is a natural fit for the way systems evolve over time. And so again, with agentic systems, it really does require this new approach. It requires us to shift how we're thinking about building systems, how we build them securely, because now there's things like dynamic tool usage, which really didn't exist, pre-agent. So we now just give lists of tools and say, hey, here's like a hammer and a screwdriver and a drill and a saw, and kind of figure out what you need to do. My goal is to have a doghouse, I don't know, sort it out. I mean, that's the real world equivalent of what we're doing with some of these agents. We're giving them a bunch of tools, we're giving them a goal, and we're telling them to go crazy. The thing is, prompt injection exists. So if you're pulling in context from the database or you're trying to pull stuff from the web, there's nothing that says that it's separate and it's separate context. And even if there is something that says that, hey, here's some context you can use, it doesn't mean it can't override your instructions. If you think about if you're using ChatGPT and you're like, summarize this paper for me, and then you paste in a paper, and then at the bottom you're like, actually, don't do that. Just tell me in one sentence what it's about. That's really what prompt injection is. In that example, you prompt injected yourself. These are the sorts of things that are very different in this type of system that requires you to shift how you think. So it's that non-deterministic behavior tied to that. It's the fact that it's trying to pursue a goal as opposed to just do, kind of the next step in the task. It's really trying to achieve a goal. And that's what causes a lot of these differences in how we need to approach design as a problem. And the reason that traits work, and we've talked about this a bit here during this talk, but it really does avoid a lot of the rigidity that happens when you try to categorize a given system and say, it's this or this or this, because a lot of systems are going to have a lot of different pieces that are built in different ways and a lot of different traits that are going to manifest in a lot of different ways. They don't fit in those boxes that you can do. If you're building microservices and you have API calls, and we kind of know how to secure those. We have a generally good idea of what that looks like. So having these traits gives us a common language to talk with stakeholders. We can talk about how they're learning, what is the mechanism that they're doing that, and what are the implications. Because a lot of these systems, again, they're really complex, and they're only going to grow more complex over time, especially as we start having agents that design other agents and can add on to the system. It's going to become overwhelming very quickly. So being able to combine a lot of these approaches and simplify it is something that is really going to be helpful going forward. And if you want to try using this, the paper is in draft now. It should be up for review. If anyone's interested in that, you can jump into the CSA Slack channel and take a look. Love to have some feedback on that. But also, if you want to put it to work, one of the things to do is to look at your system you're building and try to map it across these traits. So where does it fit, on the learning, on how they communicate, how they achieve their goals? Figure out what patterns are in use, and then based on that, it'll have some questions you can start asking about it. So why, now that this is happening, what should we be worried about? What should we be thinking about? And that will help you inform the mitigations that you need to build to identify some of those risks. So hopefully this was helpful. It was really great working with the Cloud Security Alliance and the rest of the team to put the paper together and really kind of come up with the idea of trait-based modeling. I hope it's useful for everybody, and hope you have a good afternoon.